Let's please find our seats quickly and quiet down. Today we're going to make our first step towards finance. We're going to understand how time and money mix together. So in a sense, we're going to say that time is money, and we're going to make this precise. And let me start by asking you a question. So suppose that I ask you, how much money are you willing to pay now to receive £1,000 paid in a year? Okay, so I write a piece of paper, and I write here, owner will receive £1,000 in a year. This is a nice thing to do. I mean, this is a nice thing to have. If you're willing to pay money for this, because it's a nice thing to have. And so this is a price tag. So you go into a shop now, and you can buy one of these. And the question is, how much money are you going to pay for this? What is the price on this price tag? Eventually, we're going to call the price in the price tag the present value of £1,000 paid in 1 year. So that's what we're trying to figure out today, the present values of future payments. But now, before we try to fill in the precise number here, what sort of a number am I going to put here? Am I going to put more than £1,000? Who is willing to pay me more than £1,000 to get £1,000 in a year? Please form a nice queue here, and I'll issue these certificates to you. Are you willing to pay £1,000? Would you be willing to pay less than £1,000? Would you pay £20 for this? Okay, about 900. Okay, so the purpose of this little experiment, in which you're not cooperating very much, is to figure out that £1,000 paid in the future is worth now less than £1,000. Okay? So there's going to be some factor less than 1, which is going to multiply this £1,000 paid in a year to get the present value, what you're paying, what you're willing to pay now to receive this future payment. So this is what this lecture is going to be about. We're going to learn to translate money in the future to money now, and money now to money in the future. Okay, so how do we do that? But let's first figure out why time and money mix together. So the point is that money is a resource, just like other things that you use to make things. So if you're going to build a factory that makes something, you're going to have machinery, you're going to have workers and things like that. And then you're going to have money to pay for the machines and to pay for your workers and all that. So money is a resource. And just as if you were to let me use your house, which is a very nice resource, you would expect to get rent. So you can think of money being given to someone in exchange for rent. So what we normally call interest. So when you put money in a bank, the bank will pay you interest because you're renting the bank your money, and when you're taking a loan, you're going to be paying interest to the person who gave you the loan, because in a sense, the person is renting you some money. So a lender would forego the pleasure of using their money now. So I could give you a loan, or I can take my money and buy myself an ice cream. I'm going to forego the pleasure of an ice cream, and I'm going to want compensation for that. And the compensation is a rent on money, which we call interest. So if you take your available cash and you go to a bank, you deposit it, you're going to get rent on your money, on your cash, and we call that interest. And now we're going to learn how we compute interest. So normally interest is compounded, which means that there is a period on which you earn interest, And then after that period, you get your original deposit plus the interest. And then during the next period of getting interest, you're going to compute the interest not on the original amount, but on the original amount plus the first interest payment and so on. So that's what it means to compound the interest. And we're going to figure out now how banks compute these things, how we compute the interest on deposits. So if you go into a bank and you want a loan, you're going to be quoted an interest rate. And usually you're going to be quoted an annual interest rate. And then you're going to be told how interest is going to be compounded. So it's typically compounded a fixed number of times a year. So once a year or twice a year or every month and so on. And now let me tell you how the bank computes the interest on your loans. So suppose that or the interest on your savings account. Suppose that you have £8 and you deposit this in a savings account and you deposit this for n years and you're getting a yearly interest rate of R, and suppose that the interest is compounded m times a year. So during this period of n years, you're going to get how many interest payments? M times n. M interest payments every year for n years. Then if you want to know what's going to be the terminal value of your deposit, how much money you're going to have after all these n years, the answer is, well, you start with your deposit. After each compounding period, your money is going to grow by some factor. That factor is going to be 1 plus the yearly interest rate divided by the number of times interest is compounded every year. So after 1 year, you're going to have this amount of, after one period of compounding, you're going to have this amount of money. This is what happens when you compound your interest once. After 2 periods of compounding, after 2 periods of interest, you're going to get this much. At the end of the life of this deposit, you're going to be compounding interest m times n times. And then you're going to discover that you have this much money in your savings account. So for example, if I borrow £1,000 from you for 3 years and I agree to pay 5% interest compounded every 6 months, how much am I going to repay you at the end of these 3 years? Well, the original 1,000 times the factor of 1 plus 5% divided by 2, because interest is computed twice a year, to the 6, because there are going to be 6 compoundings on the interest, and the answer is going to be this much. So after 3 years, I will owe you that much. Now, I want you to notice that I'm calling this a convention. There is no mathematics in here. This is the legal definition of what does it mean when the bank says, we'll charge you this interest rate and we'll compound the interest this number of times a year. This is a legal convention. And there are other ways of doing this. There are other ways you could come up for computing interest, and many of them are even better than that. They make more sense. And we're going to see a few other ways of doing things very soon. Okay, so I've just showed you how we can start with some amount of money now, and then you end up later, and then you can discover how much money your deposit now will grow later. But now I want to go the other way around, and I want to go the other way around in a way that enables me to answer this question, enables me to put a price in this price tag. I want to take money later, and I want to convert this to money now. So you tell me you will receive this amount of money in the future. I want to know how much is that future payment worth now. So let's go back to this question I asked you, but now I'm talking about 10 years rather than 1 year, and I'm talking about £1 rather than £1,000. So how much are people willing to pay now in order to receive £1 in 10 years? So again, you can think of a piece of paper which says the owner will receive £1 in 10 years. And this is a nice thing to have, so people are willing to pay money for it. And the question is, what goes into here? And I'm giving a name to this amount of money. I'm going to call this X pounds. So what is X? Okay. So how are we going to relate X to something else we may know? Well, we're going to observe interest rates. So suppose that you go to the bank or to the British government and you ask them, if I were to deposit money with you for 10 years, how much interest are you going to pay me? So suppose that you discover that the 10-year deposits pay 3% per year, compounded yearly. Okay? Now, suppose that you take this X pounds we're trying to find and you deposit it for 10 years. With how much money are you going to end up? Well, the original X times 1 plus 3% raised to the 10, because you're going to get compounding of interest 10 times. And the number turns out to be 1.34 times X. Now, okay, so suppose that you solve for X. So suppose that you want to end up with £1. So which deposit of X is going to give you £1 in 10 years? So if you deposit this much now, after 10 years, you're going to get this number times 1.34. So this is the amount of money that you can deposit now, 74 pence, to get £1 in 10 years. And this, I claim, is what should go inside this price tag. So 74 pence is the price of £1 paid in 10 years, assuming that we observe these interest rates. Now, I'm just making a claim here. I'm claiming this is the correct price of this piece of paper. Now, what did we say about correct prices? How do I convince you that a price is correct? I have to convince you that the price is not incorrect, or that any other price is incorrect. So let me convince you that this price is correct by convincing you that any other price is incorrect. So suppose that you come to me and say, well, no, actually people are paying more than this amount of money, 1.03 to the minus 10, which is 74 pence. Suppose that I observe people paying more, an amount A, which is more than this amount of money. So let me show you that this is not going to be a stable situation. This is not going to last for very long. So what do we do? So people are paying too much for this piece of paper. What do we want to do? And this is something that you're going to do many times in this course. What happens when you observe a price which is too high? If I say you can sell these chalks for £1 million each, what do? You sell them, right? Can you hear me? Okay, so you go and you say, oh, the price is very high. Let's try to sell this and see what happens. So I sell this piece of paper for £8, and I collect that amount of money and I deposit it for 10 years, earning an interest rate of 3% a year. And then I wait for these 10 years, and after 10 years, I get my original deposit times 1.03, 1 plus 3% to the 10th. And I multiply these two numbers. My assumption is that A is bigger than this number, so this number over here is greater than 1. So someone comes to me then and after 10 years and says, remember 10 years ago you sold me this? And I say, yes. So I owe you £1. Here's your £1. So out of this amount of money, which is greater than 1, I give him £1, and then I'm left with some positive amount of money in my pocket. Okay? What do we call this? We have two different names for this. An arbitrage opportunity. I just showed you an arbitrage strategy that produces arbitrage for you. There was another name for this. 2 words. Free lunch. I just exhibit a free lunch for you, right? Okay, so now, so what do we say about free lunches in this course? There is no such a thing as a free lunch. So this price A greater than that number cannot happen. And now let's see what happens if A is less than this number I claim should go into here. Then I'm going to say this is too cheap. Let me try again to talk to you. So let's see, what happens if something is too cheap? I say, this wonderful phone I have somewhere in my pocket, I sell it for 10p. What do? Come on, it's not that difficult. You buy it, right? Okay, so I'm saying, look, there is something, and it looks like it is too cheap. So what do? We buy it. So how can we buy this thing? We first need money. So I'm going to have to borrow this price, which is too low. I'm going to exchange it for this piece of paper. I'm going to wait for 10 years. I'm going to go to the person from whom I bought this piece of paper. I'm going to collect £1. Then I'm going to repay the balance of my loan. What is the balance of my loan? Well, I took a loan of £8 at 3% for 10 years. So this is how much I owe. And then this number, under this assumption that it's less than this other number, this product is less than 1, so I can repay £1. I can repay this amount of money out of my £1, and I'm left with a positive amount of money in my pocket. And I can then go and buy myself a very small lunch, and I just exhibited a free lunch for you, right? So what do we say about this number being less than 74 pence? It's a contradiction. We're assuming that there are no free lunches in this course. So what did we discover about the price? It cannot be greater than this number. It cannot be less than this number. So it must be that number. That number happens to be 74 pence. Okay? Do you understand this little example? So congratulations. This is the first time we compute the correct price of something, and we're going to be using this technique of showing that the price is correct by showing that any other price is incorrect many times in this course. So again, the punchline here is that there are no free lunches, and I exhibited to you some free lunches which cannot happen. Okay, let me skip this a bit. Let me show you a more complicated example. Let's talk about mortgages. So what is a mortgage? A mortgage is a loan that is given with some asset being a security for the loan. So if you buy a house, you get a mortgage, which is a loan to buy the house. If you don't repay the loan, people take your house. Okay, so let's have a look at a typical such mortgage. Let's talk about £100,000 mortgage. And the terms of this loan, of this mortgage, is that you pay an interest rate of 6%, a yearly interest rate of 6%, which is compounded every month. And then you take this loan for 20 years. And the way mortgages work, which are a bit funny, is that you have mortgage payments which are all the same. So here's time 0, we're here. So after 1 month, you're going to pay some amount of money, X pounds. After 2 months, you're going to pay the same amount of money, X pounds. And so on. In 20 years, which is 20 times 12 months, you're going to pay this amount of money, X pounds, for the last time. Okay? So the question is, how do banks compute these monthly payments? So what is the monthly payment you're going to pay to repay the mortgage in 20 years? So I call this, I just realized I used the wrong letter, so I'm calling this P. So let me go back here, change all this to P's. So the question is, what is P? So let's do this in 2 steps. So let's ask ourselves first, how much is the bank willing to pay you now in order to receive P pounds in M months? In other words, from the point of view of the bank, what is the present value of P pounds paid in M months? Okay? So the question is, how does the bank translate money now to money in M months? Well, £1 now, under the terms of this loan, what happens to £1 now in M months? So in M months, this grows to £1 times 1 plus 6% divided by 12 to the M. Right? So if this amount of pounds is worth £1 now, if I ask you, how about P pounds in M month? So if you pay the bank P pounds in M month, how much is that worth now? So to get from here to there, I'm going to have to multiply by this to the minus M. Sorry, divided by 12. If you don't believe me, take this number, minus M, sorry. Take this number, multiply this by this factor to translate this back into money paid in M months, and you're going to get P, right? So this is the answer to the question you see there. This is how much the bank is willing to pay now to receive P pounds in M months. Let me repeat myself. So now you go to the bank and you say, I'm going to pay you P pounds in 1 month, and in 2 months, and in 3 months, and so on, up to in 20 times 12 months, 240 months. Okay? And you, in exchange for that, are giving me £100,000. Okay? So let's get into the head of the bank manager. He says, for me, £100,000 is the price I pay for all these payments in the future. Okay? So for me, this £100,000 is the total value of all these payments of P pounds every month. So this is P times 1 plus 0.06 divided by 12 plus P times 1 plus 0.06 divided by 12 squared, and so on. Let's write this in a more compact way. Sorry. Minus 1 and minus 2, right? The present value of P pounds paid in M months is this much. So I have a minus 1 and a minus 2 and so on. So I can write this in a more compact way. I can say the present value of all the monthly payments is the sum. Right? You ask the bank, how much are you willing to pay now in order to receive each one of these monthly payments? So each one of these, for M going from 1 to 20 times 12, is going to say, well, the sum of all these numbers as M goes from 1 to 20 times 12. Okay, so this is how much the bank is willing to pay now to receive all these payments, and how much is the bank paying you now? The bank is paying you precisely £100,000. The bank gives you £100,000 in exchange for these payments in the future. So we must have that the £100,000 is equal to the sum. Right? Do you understand this calculation? We're talking about payments occurring in the future. Each one of them has a present value, which we computed here. If you want to know the present value of all the payments, it's the sum of all the present values of all the payments. And this is what the bank is willing to pay now for all these future payments, and that is equal to the amount of money that the bank is actually paying you, which is 100,000. Okay, so now we can look at this and we can simplify this a bit, and we can write it in this form. Nothing very interesting is happening there. And now this is a geometric series. We know to sum geometric series. We can solve for p, so we can divide. P is going to be 100,000 divided by this geometric series. There it is. We can find out the sum of the geometric series, and we get some sort of a number. It happens to be 716 pounds and 43 pence. So if you go to the bank is going to say, sure, we'll give you 100,000 pounds. Every month you pay us this monthly payment. Do you have any questions about this? Can you show me some signs of life? Okay, if you don't want to say anything, let's practice moving our heads. So let me teach you a very useful trick. This means yes, and this means no. Okay? Is this making sense? Do you understand this example? All right, fine. Okay, so that's all very nice, but now I want to introduce a new way of computing interest. And this way of computing interest is going to say, instead of compounding interest every year, or every month, or every day, or every hour, or minute or second, let's compound interest continuously. So how do we do that? So here's what happens if you deposit money at an interest rate of R compounded m times a year for n years. This is this expression over here. So what happens if I compound the interest more and more frequently? So if I have more and more compoundings m every year. So I'm taking the limit of this as m goes to infinity, and now I can pull the a outside, and then I can think of this as taking something to the nth power. Raising things to the nth power is a continuous function, so I can put the limit inside the raising to the nth power operation, and I'm left with this. And now I look at this limit over here, and we all know and love this limit. This is just e to the r. So the end result of taking this limit is a, the amount you deposit, times e to the interest rate, times the number of years. Okay, so if you borrow £8 for t years at an interest rate of r compounded continuously, so that's the convention I'm introducing now. I'm telling you what does it mean to compound interest continuously. Then if you borrow that amount for t years at an interest rate of r compounded continuously, you're going to have to pay back the original amount times e to the interest rate times time. Now, why are we doing this? We're doing this because our t's are going to be very strange. I want to be able to talk about borrowing money for 3.5 days or for an infinitesimal period of time. And if you try to use the other equation we had, the other formula we had for compounding sometime, what do you do if interest is compounded every month and you borrow money for 2 hours? How are you going to use that formula? So that's going to be tough, but now you don't care about the number of compoundings per year. You just look at continuous compounding, and you can talk about borrowing money for 3 minutes without any problem. So I want to introduce this way of compounding interest, and I want to emphasize in red, big, bold letters that in this course, unless I tell you otherwise, that's the way we're going to compute interest. All interest rates in this course are going to be assumed to be continuously compounded. Okay? So each time you see interest rates, say to yourself, continuously compounded, unless I tell you otherwise. Okay, now let me say one last thing about interest rates. So I mentioned that there are various ways in which you can compute interest rates. So let's see it. 3 ways which we've seen today. And I want to show you that these are just conventions. You can look at the same thing in nature. You can describe it using 3 different conventions. So let's describe the following thing we observe in nature. You observe a deposit of £100 turning into a balance of £110 in 1 year. So how can we describe this phenomenon of money growing using various interest rates? Well, you can say this deposit got a 10% interest rate compounded yearly, right? You start with £100, and then if your interest rate is 10%, so you have 0.1 divided by 1, because there's one compounding every year, times 1 year times the number of compoundings per year, and you get £110. Okay, that was easy. But we can describe the same transaction using an interest rate which is compounded every 6 months. So how would we do that? We would say, okay, we observe £100 going in, £110 going out. We're talking about an interest rate of R compounded twice a year. So what must be happening is this, and now you can solve for R. There is an interest rate compounded twice a year that does this for you, takes you from £100 to 110. How do we find it? Well, let's see, 1 plus R over 2 is going to be the square root of 11 over 10, the square root of 1.1 if you prefer. You solve for R, and you get that R is twice the square root of 1.1 minus 1. And you can say, wait a minute, maybe what happened here is that this person deposited money and got continuously compounded interest. So if that's the case, what happened here? We deposited £100, we collected £110, we got an interest rate, a continuously compounded interest rate of R for 1 year. So this is what must be happening, in which case the continuously compounded interest rate can be solved from here. It's going to be the natural log of 1.1. Right? So there are many conventions to describe the same thing. You can come up with your own conventions if you want, and that's going to be fine, as long as the other party to your business is happy with that. That's going to be fine. Okay, what do we want to do next? What I want to do next is I want to show you something else that exists in nature, which are these things. So I'm going to pass these pieces of paper around. Let's start with this here. And as you look at these pieces of paper, you can feel free to take them out of the plastic thing. You're going to see it's a big, complicated piece of paper. One of them is in German. But they both have little coupons that you can detach. Now, don't detach the coupons. I need them. But you could detach the coupons if you wanted. And if you look closely at the coupons, they have dates on them. So these things you're going to be holding in your hand very soon are called bonds. What is a bond? A bond is a financial asset. It's a contract. It's a contract that says owner will receive payments described in the coupons, plus final payment on maturity date. Okay, this is a nice thing to have. And if it's a nice thing to have, people are willing to pay money for it. This thing is a bond. And the thing that goes into here is the bond price. So we're going to ask ourselves, how are bond prices related to other things we've seen so far? So we've seen interest rates and so on. So let's try to figure out what is the correct price of a bond, what is the correct bond price in terms of something else. But before we do that, let's try to figure out exactly what this is. So these are pieces of paper which are it can be, in theory, be issued by anyone. I can sell you some of this if you want to buy from me some. But usually governments and big corporations issue these bonds. That's how, instead of going to a bank, instead of the British government going to a bank and saying, oh, please lend me some money, they issue bonds, which they sell to the public and other corporations, and that's how they raise money. And when you look at these bonds, as I told you, there's going to be, there are going to be coupons. There's a face value. The face value is this final payment. So the bond is going to say in small print, in these bonds that you're passing around, in the small print it's going to say on the final date of this bond, on the maturity of this bond, you're going to get a final payment of such and such. There's a name for this final payment. It's called the face value of the bond, and the date in which the face value is paid to the owner of the bond is called the maturity date. And together with this final payment, you have another collection of payments, which are the coupons. So each one of these coupons is going to say something like, you will get £5 in 6 months, and you would get another £5 in 12 months, and another £5 in 18 months, and so on. Now, I've discovered today that these links don't necessarily work, but let me take you somewhere else. So here is a collection of bonds issued by the UK government. So let's have a look at an example of these. Let's have a look at this one over here. So I'm looking at a bond today. It's a bond issued by the UK government. It's called a gilt. This is the technical name for bonds issued by the UK government. They're called gilts for some strange reason. It has an 8% here, which I'm going to tell you what it means very soon. But the first thing I want to see is this date over here. The maturity of this bond is June 2021. That's going to be the date of the final payment. That's a maturity date. And what is the final payment of this bond? It's not described there, but all government bonds, all UK government bonds, as far as I know, they all have a face value of £100. Okay, so on the final day, on June 2021, you will receive £100. Now, in addition to that, you're going to get coupons. Now, what are the coupons here? Again, you cannot see that completely there. The only thing you can see there is 8%. What is this 8%? Yikes. What does this 8% mean? It means every year you're going to get 8% of the face value. And here's something which is not specified there. These payments, these coupon payments, come every 6 months. This is true for all UK government bonds, all UK gilts. So what's going to happen to the owner of this bond is going to get 8% of £100, which is £8 every year, paid twice a year. So every 6 months, that person is going to get £4. Okay? So in 6 months, or the first payment is going to be £4. The second payment after 6 months is going to be another £4, and so on. Then there's going to be a penultimate payment of £4. And the last payment is going to be the £100 face value plus the last coupon of £4. This is the final payment. Okay? This is what this bond is, this bond I'm describing here. And now you can see that people are willing to pay this much money to own this. So if you look at this collection of payments, you look at the price tag of this, and the price tag in this case is £118 point something, 87. Okay? So this line describes one UK government bond, and it means that. So I showed you some UK gilts. I can show you some other things, but the links are not working as well as I wanted them to work. So let me give you an artificial example. So suppose that I come to you and I say, I'm talking about a bond. Is there a question about anything? Suppose that I'm telling you about a bond which has a face value of £100. I tell you that it pays 6% annual interest, and it has 2 years to maturity, and its coupons are semi-annual, half-yearly. So you get a coupon payment every 6 months. So what is this bond going to do for you? So let's draw a picture corresponding to this one. So what's going to happen if you own this bond? So one thing we know for sure is that in 2 years, we're going to get the face value. So what are you going to get? This is 2 years. This is my time axis. We are at time 0. At time 2, you're going to get £100. What else is going to happen? At the end of the life of this bond, you also get the coupon payment. What is a coupon payment? It's 6% of £100 divided by 2. So in 2 years, you're going to get £103. What else is going to happen? Well, half a year before that, at time equals 1.5, you're going to get a coupon payment of £3. 6 months before that, after 1 year, you're going to get another £3. And in 6 months, you're going to get another £3. Okay? This is what it means to have this bond. It's a piece of paper that entitles you to this payment. So you're going to get £3 in 6 months, £3 in 12 months, £3 in 18 months, and £103 in 24 months. Okay? Do you understand this example? All right. So now let's make the first step to finding a relation between the prices of bonds and other things we've seen so far, which are interest rates. So let's talk about zero coupon bonds. So what is a zero coupon bond? It's a bond which has no coupons. So it just gives you one payment. And that payment is the face value at the maturity of the bond. So suppose that you're looking at a zero coupon bond with a face value of £1, and suppose that it matures in T years. So we have a piece of paper, just like the pieces of paper we've seen at the beginning of this lecture, that says you're entitled to get a payment of £1 in T years. I owe owner of this piece of paper £1 paid in T years. Sorry, I sense that there is some question floating around or some comment. Share it with us. Any questions about anything? Anything you would like to share with us? Okay. Let's have a look at this piece of paper. This piece of paper is going to pay you £1 in T years. It's a zero coupon bond. It just consists of one payment in the future. And the question is, how am I going to price this? What's going to be the correct price to put here? Let's call this correct price P. Well, this is another way of saying P is the present value of £1 paid in T years. And we know to find this. So let's link the price of this £1 paid in T years to something we know already, which is interest rates. So let's go to the bank and ask the bank, how much interest do you pay or do you give for deposits or loans for T years? Okay, so the bank is going to give you an answer, and let's call that answer R. Then I claim that the number that goes in here, So I'm going to do two things for you. Eventually I'm going to show you that this price here, P, must be e to the minus RT, e to the minus interest rates times time. So how am I going to show you that this is the correct price of this bond? I'm going to repeat what I've done before. I'm going to show you that any other price is incorrect. So let's start by saying, let's convince ourselves that this price cannot exceed e to the minus RT. So if the price exceeds e to the minus RT, then if we are correct, if this is really the correct price, then the bond is too expensive. So we sell it for P, we take P pounds, we deposit this for T years. After T years, earning an interest rate of R, a continuously compounded interest rate of R, we obtain a terminal value of our deposit, which is the original amount times e to the interest rate times time. Under the assumption that P exceeds e to the minus RT, this product here is greater than 1. Someone is going to come to me and demand £1. We give them their £1, and I pocket the difference. So P cannot exceed e to the minus RT. And now, so that's a contradiction. If this happens, we've just exhibited a free lunch, an arbitrage opportunity. And let me also convince you that P cannot be less than e to the minus RT. What happens if P is less than e to the minus RT? The bond is too cheap. Now I want you to talk to me and tell me, what do you do when something is too cheap? You buy it. You buy it. So you have to buy this thing which is too cheap. First, you have to arrange for some money to have. You borrow P pounds. You buy the bond. You wait for 2 years. Now you have to repay this much money, P times e to the RT, which under our assumption is less than 1, which is fine because you're going to now go to someone and say, give me my £1. They're going to give you a £1. And then you're going to be left with this positive amount of money in your pocket, which is what we're calling a free lunch. So this inequality cannot happen as well. So this being greater than that leads you to a contradiction. This being less than that leads you to another contradiction. So the price of this bond is related to interest rates in precisely this form. So now we know what to write in here. Okay? Okay, next time we're going to look into this a bit more. Did you have a chance to see the bonds I was circulating around? Okay. Can the person who has the bonds